Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the video where I actually have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 27 to the power of 27 plus 27 to the power of 27 plus 27 to the power of 27. Now, the first thing I'm going to do is I'm going to factor out 27 to the power of 27. So now I have 27 to the power of 27 times 27 to the power of 27 divided by 20 to the power of 7 to the power of 27 is 1, because anything divided by itself is 1. So I have 1 plus 1 plus 1. Now 1 plus 1 plus 1 is 3. So I have 27 to the power of 27 times 3. Now, if we want to multiply these two, we want to have them be the same bases. So 3, this can't be simplified. So the only thing that's left to simplify is 27. So now 27, this is equal to 3 to the power of what? Well, 3 to the power of 1, this is equal to 3. 3 to the power of 2, this is equal to 9. 3 to the power of 3, this is equal to 27. So if x is 3, then I would have 3 to the power of 3 to the power of 27 times 3 to the power of 1. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of 27 is going to equal 3 to the power of 3 times 27 times 3 to the power of 1. 3 times 27 is 81. So I have 3 to the power of 81 times 3 to the power of 1. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 3 to the power of 81 times 3 to the power of 1, this is going to equal 3 to the power of 81 plus 1. 81 plus 1 is 82, so I have 3 to the power of 82. So this is my answer. Alright, so I have 3 to the power of x plus 3 to the power of x is equal to 10. So I want to find the value of x. So for my solution here, first start with 3 to the power of x plus 3 to the power of x is equal to 10. Now what I'm going to do is I'm going to factor out 3 to the power of x from my left-hand side, because both the terms are 3 to the power of x. So now I have 3 to the power of x times 3 to the power of x divided by 3 to the power of x is 1. So I have 1 plus 1 is equal to 10. Now 1 plus 1 is 2. So I have 3 to the power of x times 2 is equal to 10. Now I'm going to divide by 2 on both sides. So then these two cancel out, and I'll be left with 3 to the power of x is equal to 10 divided by 2 is 5. Now to solve this problem, I'm going to be taking the log on both sides. So now I have log 3 to the power of x is equal to log 5. And now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So in this case, I have log 3 to the power of x. I can move my exponent x to the front. So I'd have x times log 3 is equal to log 5. Now I can go ahead and divide both sides by log 3. So then these two cancel out, and I'll be left with x is equal to log 5 over log 3. Now log 5, this is equal to 0.6990, and log 3, this is equal to 0.477. So now I have x is equal to 0.6990 over 0.477. And this is equal to approximately 1.464. So 1.464 is our answer. Alright, so I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. Now the first thing I'm going to do is, because my left-hand side has all our terms being 4 to the power of x, I'm going to factor out 4 to the power of x. So now I have 4 to the power of x times, well, 4 to the power of x divided by 4 to the power of x is 1, because anything divided by itself is 1, and because all my terms are 4 to the power of x, I have 1 plus 1 plus 1 plus 1. And this is equal to 1. Now, if I simplify this in the parentheses, I get 4 to the power of x times 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, so I have 4 to the power of x times 4 is equal to 1. Now what I'm going to do is 1 here, this is the same thing as 4 to the power of 0. So I have 4 to the power of x times 4 is equal to 4 to the power of 0. Now 4 is the same thing as 4 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So now 4 to the power of x times 4 to the power of 1 is going to equal 4 to the power of x plus 1. And now I have this is equal to 4 to the power of 0. Now if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So this means that x plus 1 is equal to 0. So now to solve this, simply subtract 1 on both sides, and now I have x is equal to negative 1. So this is my answer. Now another method to doing this is, well, we first start with 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1. So I factor out 4 to the power of x, so I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1. Now if I simplify what's in the parentheses, I get 4 to the power of x times 4 is equal to 1. And now instead of multiplying these two, I'm going to divide both sides by 4. So then these two will cancel out. Now 4 to the power of x is equal to 1 over 4. Now if I have something in the form 1 over a to the power of n, this is the same thing as a to the power of negative n. So in this case, I have 1 over 4 to the power of 1. And now this is going to equal 4 to the power of negative 1. So I have 4 to the power of x is equal to 4 to the power of negative 1. And if I have something in the form a to the power of m is equal to a to the power of n, then m is equal to n. So in this case, x is equal to negative 1. So this is another method of solving this problem. Now to check, so I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 1, and x is equal to negative 1. So now I have 4 to the power of negative 1 plus 4 to the power of negative 1 plus 4 to the power of negative 1 plus 4 to the power of negative 1 is equal to 1. And if I have something in the form a to the power of negative 1, this is equal to 1 over a. So 4 to the power of negative 1, this is going to equal 1 over 4. So I have 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 is equal to 1. Now 1 over 4 plus 1 over 4, that's going to equal 2 over 4. So I have 2 over 4 plus, again, 1 over 4 plus 1 over 4, that's going to equal 2 over 4. And 2 over 4 plus 2 over 4, that's going to equal 4 over 4. So I have 4 over 4 equals 1, and anything divided by itself is 1, so I have 1 is equal to 1, and this is right, so our solution is right as well. Alright, so I have 2 to the power of x squared over 4 to the power of x is equal to 16. Now 16 here, this is equal to 2 to the power of 4. So now I have 2x squared over 4 to the power of x is equal to 2 to the power of 4. Now, as you can see, I'm trying to put 2 in all my terms here. So the only one remaining is 4 to the power of x. And 4, this is the same thing as 2 squared. So I'm going to replace 2 squared with 4 to the power, with 4. So now I have 2x squared over 2 squared to the power of x is equal to 2 to the power of 4. Now, if I have something in the form, sorry, this isn't 2 to the power of 2, this is 2 to the power of x squared. Now I have this power of 2 to the power of 2 to the power of x is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, that's going to equal 2 to the power of 2 times x. And 2 times x is 2x, so now I have 2 to the power of x squared over 2 to the power of 2x is equal to 2 to the power of 4. And now as you see, all my bases here are 2. So now this actually makes it much easier to solve. So first off, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x squared over 2 to the power of 2x, this can equal 2 to the power of x squared minus 2x. Now this is equal to 2 to the power of 4. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, I have 2 to the power of x squared minus 2x is equal to 2 to the power of 4. Both my bases here are the same, meaning my exponents here are the same as well. So x squared minus 2x is equal to 4. So now to solve this, I'm going to subtract 4 on both sides so that these two cancel out, and I'll have x squared minus 2x minus 4 is equal to 0. And now, as you can see, I have a quadratic equation. And to solve this, I'm going to be using the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to negative 2, and c is equal to negative 4. So now I have x is equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 4, all over 2 times a, so 2 times 1. So now I have x is equal to negative, and negative is positive, so positive 2 plus or minus the square root of negative 2 squared is 4 minus 4 times 1 is 4, 4 times negative 4 is negative 16, so I have positive 16 over 2 times 1, which is 2. Now I have x is equal to 2 plus or minus the square root of 4 plus 16 is 20 over 2. And now the square root of 20 is equal to 10 times 2, which is equal to 5 times 2. So now 20 is equal to 2 root 5 over 2. So now if I divide both these by 2, 2 divided by 2 is 1, so I have 1 plus or minus, these two cancel out, so the square root of 5. So 1 plus or minus the square root of 5 is my answer. To be specific, I have 1 plus the square root of 5, and I have 1 minus the square root of 5. And these two are my answers. Alright, so in this video, I'm going to solve the equation a squared minus b squared is equal to 49. So to solve this, I'm going to use the property that states that if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. In this case, a squared minus b squared, a is x and b is y, so this turns into a plus b times a minus b is equal to 49. Now from here, I can rewrite 49 as 7 times, or sorry, not 7, 49 times 1. 49 is equal to 49 times 1, so that's true. And this I can rewrite as 7 times 7. Now, we obviously know that a plus b is going to be greater than a minus b. So keeping this in mind, this means that we can't rewrite a plus b times a minus b as 7 times 7, as 7 and 7 are equal. So this possibility is out of the way, and 49 times 1 is the only possibility here. Meaning we're going back to a plus b times a minus b is equal to 49 times 1. So because a plus b is greater than a minus b, we can say that a plus b is equal to 49 and a minus b is equal to 1 because a minus b, 1 is less than 49 and a minus b is less than a plus b. And this is also in the form a number times a number. So, and notice how this is equal to a number times another number. So we can say that a plus b is equal to 49 and a minus b is equal to 1. So what we have here is a system of equations, and I'm going to add these system equations. A plus a is 2a, b and negative b cancel out, and 49 plus 1 is 50. So I get that 2a is equal to 50, and if I divide both sides by 2, these two cancel out, and I get a is equal to 25. Now that we know that a is equal to 25, remember how we said that a plus b is equal to 49. So this means that 25 plus b is equal to 49, and b is equal to 49 minus 25, which is 24. So a equals 25 and b equals 24.